Hello everyone and welcome. Today I'm going to show you my implementation of an AI agent powered by OpenAI's GPT-4o model using the Google Agent Development Kit, the Google Maps MCP Server, and Opik. This project is largely inspired by the How to Build an Agent with MCP and Full Observability in Python video from Santiago Valderrama that's uploaded to the Underfitted YouTube channel. I highly suggest you take a look at it. I'm going to put a link to it down below in the description. For this project, we'll be using the Google Agent Development Kit, which is a Python framework that allows you to build AI agents, connecting them to large language models. You can use Google's models such as Gemini, but you can also use Anthropic's and OpenAI's models. And in this case, I'm using the GPT-4o model. In this project, we're also using the Model Context Protocol, or MCP, where we are able to give our AI agents access to sources of data as well as tools that allows our agent to, along with large language models, to perform actions. So we can ask our model to retrieve reviews from Google Maps, for instance, or to write a piece of code, and it does just that. It also helps the agent retrieve information that goes beyond the training data of the large language model. We'll also be using the Google Maps MCP Server that has a bunch of tools that our agent can use to perform actions. So it can retrieve information about specific places, calculate distances and travel times, access elevation information, get detailed route information between points, including step-by-step navigation instructions, which is really cool. And this is going to allow our agent to provide more context-aware responses, more high-quality responses to our queries. Finally, we'll be using Comet to evaluate the relationship between our agent, the large language model, the MCP server, and its tools, and get more information about input and output data. Here we have our project. We can run it using UV Run ADK Web. Here we have our beautiful web UI. We can select our agent up here, and I can ask it to give me driving directions from São Paulo to Campinas. So you can see here how the agent uses the maps directions tools, and it obtains from the MCP server this information that is necessary to provide an answer to the user. So here we have all the driving directions from São Paulo to Campinas step by step. We have 25 steps in total. And here we have the function call, the function responses, and the text, which is the output of our agent to the user. By clicking here in function calls, we can see the OpenAI agent calling the maps directions function. We can see the details here, such as the arguments like origin São Paulo, destination Campinas, mode driving, which is extremely important. The next event shows the response from the tool maps directions to the OpenAI agent, which is the name that I've selected for my agent here. So here we have all the information that is then going to be used to provide the answer to the user. You can also ask the agent to find reviews on Google for the Eiffel Tower. So we can see here that the model used the Map Search Places tool to search for the Eiffel Tower, and then it used the Maps Place details to get more information, such as the Eiffel Tower website, the address, the ratings on Google 4.7, the opening hours, and we can see here once more the function calls, the responses. I can also ask the agent to tell me what place is located at a specific coordinate and ask for more information, such as the full address of that place. And once more, you can see the agent using the tools that are available. Thanks to the MCP server, it is using the Maps Reverse Geocode tool, and it correctly identifies that coordinate traces back to the Empire State Building area, and it gives me the full address. So here on Comet, we have all the interactions that we've had between the agents. So we have the input here, we have the output, so we can click to get more details. We can see that the total time was 10.5 seconds to get the information of the coordinates. In total, the total amount of tokens was 11,429, and the estimated cost for running this query was of about 0.015 cents. So here we have the input in JSON and the output in JSON as well. In LLM calls, we have even more information. And here in this JSON file, we have the entire interaction with the AI agent. So we have here my first query here. So give me drive interactions from São Paulo to Campinas. And then it gives me the directions. And then there's also the find reviews on Google for the Eiffel Tower. And we have the entire interaction here. This is the entire GitHub repo for this project. Here we have more details. So feel free to take a look at it, and feel free to collaborate if you'd like, or to leave a comment or a suggestion. And yeah, that's it for now. Thank you so much for watching, and I'll see you soon.